The way that one can understand ideal gas law, and I will keep writing it in this fashion, but again notice that we could write it in so many other ways. Alright, please get used to write them all in as many ways as you want. These are four variables that are related to each other, related with a constant. So the only way to really get a deeper understanding of this equation is by practicing. And in this case, we are going to solve a problem that is asking a very generic question. So imagine that you have four identical containers. We have four identical containers. With some imagination, you'll have to imagine that these are four identical containers, 1 liter each, 1 liter, and in each of them there's different compounds. Here there's helium, there's chlorine, there is methane, there is ammonia. Okay, ammonia is on the edge of being an ideal gas, so careful with that. As soon as your gas starts forming hydrogen bonds, it may start deviating from ideality, and so remember the assumptions that we had said when going into ideal gas formulation. In this case, so each of them, the temperature is the same, 0 Celsius, and the pressure is the same, 1 atmosphere. Okay. The question is, do they have the same number of moles? And do they have the same number of grams? Alright, let's look into this equation. Notice that volume, temperature, and pressure are determined. PV equals nRT is relating four variables. The moment you fix three of them, the fourth one is also fixed. So the number of moles is also determined by PV equals nRT, PVRT, where pressure is 1 atmosphere, volume is 1 liter, then R would be 0.082 atmosphere liter mole Kelvin, and temperature 0 Celsius is the same as 273 Kelvin. Alright, so for the four containers, the number of moles is the same. The number of moles is the same. Okay. However, how about mass? How about number of grams? Well, the number of moles is the same, but notice that when converting moles into grams, so what you would need to use is the atomic or molecular weight. So for methane, the atomic weight is 16. So for number of moles, in 1 mole, 16 grams of methane. Okay. For ammonia, you would have the same number of moles, but when converting them into grams, in 1 mole, the number is 14 plus 3, it's 17 grams. You're going to have different number of grams. Okay, so this is important. It's important to understand that PV equals nRT, the N is number of moles, and that's common regardless of the gas. However, different gases have different masses, therefore the number of grams may not be the same. Hopefully that makes some sense. Before we finish this video, sometimes in problems you may see a magnitude called the molar volume. The molar volume is the volume that occupies 1 mole. So the equation PV nRT sometimes is simplified as PVM RT. Whoops, what happened? Where's the N? The N has been divided by, the V is divided by N. This is what we call molar volume. And sometimes you may see the ideal gas equation expressed in terms of molar volume. In this case, it's just that the volume will be expressed in units of volume, say liters per mole. Okay, just something to keep in mind.